Welcome! In this series of short videos, we will look at topics common to both the PowerBasic console and Windows compilers. Today we will look at how to extend the use of the parse command. Today we're going to look at some of the functions in one of our libraries, which is going to give us the ability to extend the use of the parse command. The parse command on its own is a very useful inbuilt function to both the PowerBasic window and console compilers. It enables you to do a great deal of manipulation on strings. We have utilised the parse command within some functions within the PB Common Strings library, and we're going to explore some of the functions within this library. First of all, we're going to create a new function in this application called insertString. The output from this function is going to be a string, and we're going to print this out to our console log. So let's go and create this new function. This function is going to give us an easy way to demonstrate the use of data templates. First of all, we will create a local variable called dataTemplate to hold our data. And as you can see, we've populated this variable with 4 values, A, B, C and D, in a string which is delimited by the pipe character. And to test out the basic functionality of this function, we're going to push this string out to our log. If we run the application as it stands, we will see the template is pushed out to our log. So let's go back to the code, and in our new function, we want to insert data into one of the elements of this data template. To insert a string into this data template, we're going to be using a function in our library called Parse Put. It takes 4 parameters. So let's create some local variables for these parameters. We've created a local variable called target, which is going to be the string to hold the target data, the output from our Parse Put function. And the 3 additional variables are the delimiter, in this case the pipe character, the element number that we wish to update, and finally the value we want to insert into and replace what's currently within that element. So the delimiter we can set to the pipe character. The element we want to replace is the second element. The second element in our string at the moment currently contains the value B. And what we want to push in to replace that B is the string new value. And we will make the call to the Parse Put function, which is the function within our library with its 4 parameters, the data template, the delimiter, the element we wish to amend, and the value we wish to put into that string. And the output from the Parse Put function will be put into our target variable. So what we should see is our data template should originally start with ABCD, and its value after the Parse Put command should have the value B replaced with the string new value. So let's try running the application now to see if we achieve that. And there is our template shown on screen with its original values, and our target now has a new value within the second element of that string. So we have successfully taken a string and replaced the second element in the delimited list. If we go into our library and have a look at the Parse Put function, we can see the code which performs these actions. Within this function, we have some special handling for delimiters where they are comma delimiters. This is to handle the special case for comma delimited. We're also making use of the parse count function, which is inbuilt to PowerBasic, to check for values which are beyond the range of the string. For example, if the element given in the parameter list is greater than the number of elements within the string, then the original string will be returned unchanged. And we're making use of 2 inbuilt functions to our library, startRangeParse and endRangeParse. We'll cover them shortly. So having inserted a string into a delimited template, can we find the first instance of a string in a template and return the element number, reading from the left of the string? Let's create a new function to let us do that. As before, we're printing the output from this new function out to our log. The output from this function is going to be a number, so we're using the format command to format it into a string before we send it to the fun log function. So let's go and create the find string function. So here is our new function, and as before we set up 3 local variables to allow us to handle the data. We're going to store the data in a template, and we're going to have a search criteria string and a delimiter. In this case, our data template here is going to contain 4 values, all comma delimited: ID, name, department, and division. This could be the header of a CSV file. And as we did in the last function, we're sending that template out to our log. And we're now going to populate the delimiter and the search criteria. So in this case, our delimiter is the comma. And the search criteria, the element we're looking for, is the word department. As we can see from the template, reading from the left-hand side of the string, the department is the 3rd element. And we're now going to use another function within our library called Parse Find. It takes 3 parameters: the original string, in this case our data template, the delimiter, and the search criteria, the string we're actually searching for. And this will return a number, which is the element within the string that the search criteria has been found. So as we're looking for the word department, it should return the value 3. So let's run the application and see what we get. And there we can see on screen we have the template of the 4 values. We're searching for department, and it's returning a value of 3, which is the 3rd element in our template string. So this can be used to look at a CSV file header to determine where a particular column is in the file. If your application uses this to determine the column number on which you need to do manipulations, should the file arrive the next time with an additional column before your column, your code will still work, because it will search out the department column and find it quite successfully. As long as each of the columns is uniquely named, the code should have no problems. So if we have a look in the Common Strings library to see where the Parse Find function is. And there is Parse Find. As before, it has some special handling for comma delimited. And we're using the parse count command to work out how many elements are actually in our string. And the parse command is used to return the actual value. So that's searching a template string from the left-hand side of the string. We can also search from the right-hand side of the string. And we're going to create another function to allow us to do that quite easily, called findStringWrite. And as we did before, we're going to use 3 local variables, one for the data template, one for the search criteria, and one for the delimiter. As before, we're setting the data template with 4 values: ID, name, department, and division. And as we did in the last function, we're setting our delimiter to be a comma and the search criteria to be department. Only this time we're going to be calling a Parse Find reverse function within our library. It will take the same parameters, but it will read the data template variable from the right-hand side. So department should be the 2nd column from the right-hand side. So if we run the code now, we'll see it returns -2. -2 means we're reading from the right-hand side and we've found the 2nd column. With the parse command, minus numbers means we always read from the right-hand side. So what if the string we are reading has embedded commas? Say for example, the final column is not just called division, it's called division, organization. You would normally expect these to be wrapped in double quotes. So we have a double quote before the word division and a double quote following the word organization. So the word department should still be -2. So if we run our code again, we'll see the value is still coming out as -2, as division, organization is in double quotes, and the parse command handles that quite nicely. So the final function we're going to create today is to allow us to print the first few elements of a string. And we're going to create a function called printLeftData. In this function, we have 4 local variables: data template, which is a string to hold the template data, search criteria to hold the search criteria we're looking for, end element being the ending element number. and delimiter being the delimiter of the string. If we set our data template up as we did before with its 4 values, ID, name, department and division, our delimiter is going to be populated with a comma, and our search criteria is again going to be department. So the purpose of this function is we want to print all the data in our data template up to and including the column department. So we'll be excluding the division column. So first we can use Parse Find to find the element number of our search criteria. This should return the value 3, as the department is the third element of our string. Now we need to return the data in the template up until and including the search criteria. And this is where we can use the start range parse function we saw earlier. It again takes 3 parameters, the data template, the delimiter, and the end element, which we have just populated. And this string is the return of this function. If we run the application now, we can see our template has the 4 values, and our target has only 3. It has the ID, the name, and the department, including the last delimiter. So start range parse can be used to look at the left-hand side of any delimited string. If we look at the common strings library, we'll see there's also an end range parse, which does exactly the same thing, but from the right-hand side of the string. And as before, we have special handling for comma delimited strings. Where we have embedded commas, as in here, we are using the wrap command to wrap the output in double quotes. For example, if our data template string had the division organization as we had before, if we print this out now, we will see our template is still with division organization and our target works exactly the same, ID, name and department. So the addition of this library to your application will give you more flexibility when it comes to manipulating strings. And if you do a lot of manipulation within your applications, this will save you a great deal of time. However, that's it for today. Thank you for watching.